So from the recurrence formula, showing that the whatever function satisfy the recurrence formula satisfy the spherical Bessel function, spherical Bessel equation, right?
Most of the terms, particularly any.
Okay.
Most terms can start with 4 terms that I.
Yeah. Right. There's really no there's no magic. It's just see if you finally cancel all the terms. Just use the 2 and then finally see if you can. We can try. No. Jack, do you have question or anything? So just see if we can struggle through this. This is 7.5. The 2 recurrence formula you supposedly easy to derive, right? I'm ignoring the argument x, so right, the function plus 1 and then the subtraction is n factor n minus n plus 1 f n plus 1 is to n plus 1 f sub n pi. Okay, and you want to show that the question asks you to show that this f sub n that satisfy this set of recurrence formulas satisfy the Spherical Bessel special equation. Now, now come the struggle. Let's see if we can struggle with that. All right. Did I copy everything wrong? Everything right? So if I miss anything, then we'll not get the answer. Right. Okay, so hopefully assuming those are correct. So only thing so you have derivative and second derivative. So and you already have a derivative here. So supposedly you take another derivative, you'll get the second derivative. So just take another derivative. So that become pi. So the double pi, this become pi. And you divide it by 2m plus 1. That would be the double derivative. So it's n x n minus 1 pi minus n plus 1 x n plus 1 pi divided by 2n plus 1. So that's this one, right? And then and this one is just basically the same, except now you don't need to take derivative. The rest.
In the.
Yeah. Okay. And then the rest is just Hopefully those will cancel later. Okay, so this equals to that, and now the next one is you still have derivatives. So you apply this again, but then now you shift the n. X squared. No, you have to, for the first one, the coefficient, and then now you shift that n to n minus 1. So that becomes n minus 1. And this becomes n minus 2, right? And then minus n minus 1 plus n, fn. And then n minus 1 to n minus 1, right? So that's the first term. And then the second term, plus 1, n plus 1. Same thing, you shift the n, now this become n plus 1. N plus 1, fn minus n plus 2, right? N plus 2 divided by n plus 1 to n plus 3, right? That this term, right? And now the rest you can assume that they will cancel. So you just copy the rest. Hopefully that will work. Right, please. Right. Then so the next thing is to get rid of these n plus 2 or n minus 2. And you could use that. You can use the first one to eliminate that. So supposedly, so basically for n minus 2, you shift it to n minus 1, right? And so that will be this one with this one minus that one. Right. So you have I mean, to simplify, I think the first 3 terms, that did I get the bracket right? The bracket is x squared. It's up to here only, right? right. So all 3 terms has 2n plus 1, right? Probably you can get this. It has this has an x squared. This has an x, right? You can pull out the x over 2n plus 1 out. Hopefully that will help to not carry too many factors, right? And so now these 3 terms I group together, and then so now let's see what we have. So for this term, for this one, we have n minus 1, n minus 1. Now using this one, you have n becomes 2n minus 1. N becomes n minus 1. This becomes 2n minus 1. Wait. There's x. We just pull out x. There's an x here. Right. 2n minus 1 over x. Fn minus 1. And then minus this one, which is Fn. That's this term, right? And then this term. Wait, do I have simplification for this term first? Because there's a Fn also. Right? You have minus n squared divided by 2n plus, I think this is out, minus n squared. Or maybe it's just combine these two terms, this term and this term together. Right? And that becomes a minus. This is minus, this is also minus. Right? Yeah, right. So just combining the two terms first. And well, let's see what we could. I mean, this one doesn't need to simplify, but minus you have n squared over 2n minus 1, right? For this one, and then for this one is n plus 1 squared 2n plus 3, right? And there's x also. This will also multiply by x. X. All right. So let's take care of these two terms. Finally, is this one. So minus plus. You want to take out 2n plus 1, so it's there's an x, and then n plus 1, n plus 2, n plus 3. Right. And then this is n plus 1. So you shift this to n plus 1. So this n plus 1 equals to this 2n plus 3 over x f n plus 1, right? And then minus fn. Okay, so that took care of this term. Right. So we got all this within this bracket, and then the next one is you're taking out x and 2n plus 1, so you have 2. And fn minus 1 and plus 1, fn minus plus 1. So that's this term, these two terms, and then the last one is just to copy this one. Now, hopefully, I'll come if we have cancellation, right? We have C. So you have the n minus 1 term. So all the good thing is all the this what the x cancel for f n minus 1. X cancel. So this you have f n minus 1, right? And there's also n minus 1 term, and this just for this term, this because this all they are combining, so this need to write another term. So this cancel this cancel that. This becomes n times n minus 1. This is multiplied by this way, and but this term you have this one, so you have plus 2n. Is it a plus? Right. You can use it. No. I copied it wrong. Right? This n minus 1, right? N times n minus 1, right? This cancel, x cancel, and then plus 2n. Yeah, that's more like it. Plus 2n. And that's fn minus 1, right? And why don't we do the fn plus 1 first and then get back to this one. So this one is the same structure. This cancel with this, x cancel with that. And you have n plus 1, n plus 2, right? And then minus 2, n plus 1. That is fn plus 1. All right. Now we've come to fn. Fn, how many is yep, this one is an fn. This fn all has an x here. There's an x here, xfn, and then yep, this term is fn, this term is fn. But now we need to combine the two, so actually it's xfn coming out. So you have n minus 1, n minus 1. But this one, except it's negative. So is it all negative? This one negative. This one is negative. This one has to everything negative, right? And then this one. Did I get all the sign correct? Hopefully. Right. And then finally it's this one minus n plus 1, 2, n plus 3, fn, xfn. Right. And then plus, again, plus the same thing. Getting larger and larger. This. Why did I? Oh, this is also a plus. Did I get all the sign right? Well, you have a minus sign out. Last one is a plus. This one is a minus. Oh, this one is I'm plus 1. There's a minus. It's coming out. Yeah, there's a minus coming out. That's why I'm asking. This doesn't seem like it cancel, right? This hopefully it cancel, but I don't know. Carry out all the sign. Is the sign all correct? N minus 1. Right. So this one is coming from this double point. Yeah, this one is right. N pi is this minus that. That's correct. Right. And for this one, it's minus and then minus. And then for altogether you have, this is Fn, and this is, where did I get this one from? Where did I get this one? How did I get this one? Oh, just combining the two. Oh, this one is coming from, the shifting this one using this one. So you get, yeah, let's see if I shift it correctly. So n plus n minus 2 minus f, yeah, right. And this one is let's do is this one is combining this one and that one. Yeah, so both are minus sign, and this one is coming from this one, minus plus, and then this one is Fn plus 2 is Fn plus 2, right? It should be n plus 1 minus, yeah, seems like it's all correct. See if, let's try. Let's see this. This will give you something, some nice cancellation. N square, right? N square minus n plus 2n becomes n square plus n, becomes n times n plus 1. And for this one, you have a polar n plus 1. Your n plus 2 minus 2 becomes n, so it's n times n plus 1 again. So these two group together. Okay, that's nice. These two are nice. Okay, for this one, you have for these two terms, you can combine the denominator to n minus 1, and then you have n squared minus n plus n squared, right? Become 2n squared minus n. N squared minus n. Yeah. Right. And then the other two combined into n plus 3. And you have n plus 1 plus n plus 1 out, and n plus 1 plus n plus 2 become 2n plus 3. Right here. Oh, yeah, actually cancel. N plus 1 out. You have 2n plus 3. Oh, yeah. This one actually you can pull the n out. 2n minus 1 times n. But this one cancel with this one. This one cancel with this one. Right. Oh, that's not too bad. XFN. And then plus the rest. And then this one, it's just this one. You get the, let's continue here. So this one continue to here. So you have this one. And n times n plus 1. And then this one, just this one. 2n plus 1. Okay, of these two terms. And for this one is your n here, your n plus 1, 2n plus 1. 2n plus 1 of n. That's the curly bracket. Well, I forgot this curly bracket here. Right, and then plus the rest. The rest is x squared minus n plus 1. Right. Okay. Okay. Now you see that 2n plus 1 cancel. Oh, I forgot this x. I forgot the x. There's an x here. And then x times, what is an x? There's x. This coming from divided by x. Wait, there's an x. Wait, there's x of n. Wait, 2n plus 1 x of n. That's fine. There's an x here. Right. So they have the same proportion fn. So now let's see if we get everything correct. So you have n times n plus 1. This x cancel with this x. So this is equals to just n times n plus 1 fn for the first term. For the second term is x squared fn. Oh, this one is minus, right? 2n plus 1 is minus. This one is minus. That's more like it. So minus. But do you follow all the signs? Is it yes? Am I correct now? So this one is minus sign. This one is plus. Okay. Okay. And then plus the rest, and then you see that they cancel. This one cancel with this one cancel with this one. This is correct. No magic, just careful. Just hopefully I usually not very careful, so I also sometimes struggle a few times to get it right. So, right. Okay. So I think you have the same problem. You somewhere along the line, maybe you didn't cancel correctly, and then not getting.
Ways that could go wrong.
That's many ways. Yeah, there are many ways that can go wrong. Yeah. Well.